Hi and welcome to Math Foundations 20, Section 7.7, the Quadratic Formula, Example 4. Okay, so this example here, we're looking at a problem relating to this place that rents video games. So they rent 750 video games a month at $4.50. Okay, so basically that tells me that right now I can go right to 750 times by 450. They're making $3,375 right now on renting those games. They want to raise the rate so that they can make $7,000 per month. So they want to double the amount of money they're making by just jacking up the price. But for every dollar increase in price, they're going to rent less games. They'll rent 30 less games for every dollar they increase the price. So for example, if they raise the price to $5.50, they're going to rent 720 games. Okay, so in that case, if it was 720 times by 550, they would make a little more money. They'd make almost $4,960. Okay, so a function here that relates these values is 4.5 plus p, right? So that's 450 plus every increase of a dollar. So that's this one here, right? This is the price. And this here, 750 minus 30 times p, so that's the number of rentals they have. Right, so right now they have 750, and then take away 30 for every price increase they do of a dollar, and that equals how much money they make. So what they want to know is, okay, can the owners increase the rental rate enough to generate $7,000 per month? So is that even possible? Or if they raise their price too much, are they going to end up losing too many rentals that they won't even be able to make that money? Right, because when we think about this, it's going to be, okay, the price, it's going to go up the amount they're making, but eventually, right, if they raise the price enough, it's going to start to go down because they're going to lose so many customers. Okay, so what we're looking for here is the p-value when r equals 7,000. So it's going to be 7,000 equals 4.5 plus p, then 750 take away 30 p. Okay, so now to solve this, looking at this, it's factored, but there's a 7,000 on the one side, so we can't use this as factored form. So what we have to do is work through this by expanding these brackets and then getting everything on one side and then seeing what we can do from there. So we have 7,000 equals, and then we're going to do like FOIL here, or however you like to do that. So this here is 3,375 minus 135p plus 750p minus 30p squared. Okay, so that was from expanding that out. Now we want to bring everything to one side. So if I bring everything over to, say, this side here, if I do that, I'm going to get 30p squared minus 615p, and then I'm going to get plus 3,625 equals 0. Okay, so looking at that, looks pretty ugly for graphing, looks pretty ugly right now for factoring. We could do a little bit of factoring. We might notice that these all would be divisible by 5. So we could decrease these values by taking out a GCF of 5. So we get 5 brackets 6p squared minus 615 divided by 5 is 123p, and then plus, and that one there I think is 625, so just quickly 3,625 divided by 5, oh sorry, 725 equals 0. Okay, and now looking at that, the numbers inside there still, right, this here still doesn't look like fun to factor, so we're going to look at doing the quadratic formula. So to use the quadratic formula here, we need to identify our a, b, and c. One nice thing that we can do here is, okay, we've got this 5. What do we do with this 5? Well, we can divide the 5 out of there, divide it by the other side as well, or divide it onto the other side. This side, right, the 5 and the 5 cancel. On this side, it's 0 divided by 5, right? So this here is just a 0. So it's nice. You can just get rid of the 5 essentially. You can only do that though when it equals 0. Okay, so now we've got this in here, right, that we're looking to solve using the quadratic formula. So we can go A equals 6, B equals negative 123, C equals 725. And again, right, what we're looking for is the p-value or values that would give us the solution to this, or basically the price increase values that would give us a $7,000 in revenue. Okay, so we go to our quadratic formula. In this case, it's not x equals, in this case it's p equals, so it's p equals negative 123 plus or minus the square root of b squared minus 4 times a times by c all over 2 times 6. Right, so maybe you want to sing yourself a little quadratic formula song while you're doing that. Okay, so then the next step is to simplify. So we get p equals, and this here is 123, right, because those two negatives make a positive, plus or minus square root of, okay, working this out, we have negative 123 squared. Right, so when we calculate that, that should be 15,129. Then take away 4 times 6 times 725 equals negative 2,271, and then that's all over 12. Okay, then we look at this, and we've kind of ran into an issue. Oh, that was an accident. Ran into an issue here. We have negative 2,271. What does that tell us? Can we take the square root of a negative 2,271? Can we take the square root of a negative anything? No, we can't. So basically what this tells us is that there are no p-values that answer this, right? So here we can't take square root of negative. So again, there are no p-values that satisfy this equation. So there are no p-values that satisfy this equation. So what does that mean in terms of the question? Right, remember the question asks about making $7,000 with these rentals. And basically what we found, since there are no p-values, they can't increase the price and make $7,000. So basically it is impossible to make $7,000 on these rentals. Alright, so that was a bit of a long problem, but it's a good problem to see that, right, there's not always going to be a solution. In this case, right, if we thought of what this graph would be, right, it's like this, and it's going to be somewhere, right, above that axis, right, so it's impossible to get any p-values, or kind of depending how it's graphed, maybe it's down underneath here, but essentially, right, there are no p-intercepts, right? If there's no p-intercepts, that means it's impossible to reach that $7,000 mark. Okay, so thanks for watching, and good luck with the quadratic formula.